So here's a set of slides. They didn't go over actually because I just wrote it last 2 days. So Manju talked about the status of UCC. I am going to say mostly about UCG, but I will make some comments about UCC as well because they are very much tied together. So a brief history of time. UCG, G stands for groups. For those of you who haven't encountered this project already, started in August 18. Coincidentally, not long after I joined Huawei, I started it on my own, and my boss was kind of not from my field, so he kind of went on with it. In December, I submitted the first API proposal, and we had a year after that, we had some talks. Maybe we would upstream it. That didn't work out, as you all know. In December that year, after the workshop we did, I think it was in Austin, we formed the UCC working group. Since then, a year has passed. In September, both Huawei Cloud officially published their high-performance communication library, which you can see on the right is basically OpenMPI with some modifications, which justifies calling it HMPI. Contrary to common belief, HMPI is not Huawei MPI, even though I called it that long time. It's Hyper MPI. This comes from the marketing team, branding. And we have Open UCX with UCG smack in the middle. So that's what you get if you want to use MPI on Huawei Cloud. And actually, a day after that, end of September, Manju merged the first API we kind of all agreed on in the working group, and it was ready for the GitHub. That's symbolically pull request number 1. December 2020, 2 and something years after I started UCG, we have this update. Asterisk kind of got lost. Asterisk belongs here. So current status. Right now, there are too many versions, unfortunately. There was my personal UCG repo. Happily, I can say that's deprecated by now. We have XUCG, which is hosted courtesy of OpenUCX in its GitHub, probably courtesy of UCF, I should say. This is the master branch. Everything I do in my day-to-day work goes in here. And I got a couple of questions and a few eyebrows were raised as I said this, but this should fit any UCX version. Yes, you read correctly. Next slide. Well, not next slide, but in a couple of slides, I talk more about that. As you can imagine, since it's my code, it's not 100% stable. Far from that, I'm afraid. I have a very strong team of colleagues in China who actually maintain the more stable branch of UCG. It's located in Huawei's GitHub, which was just recently open sourced. It's based on version 1.6. If you're wondering why, that's because when I started the project 2.5 years ago, UCXB 1.6 was the UCX out there, so they just didn't change it. They stayed with what works, and it works. It's very stable, and they test it all the time. However, some of the latest stuff is not there yet. Shared memory collectives actually are, but a lot of the stuff I'm going to talk about here and I say, I support this. Actually, that's only me personally in my master branch. And the guys in China, every time they're horrified by the amount of code they need to kind of integrate and all the bugs they need to fix. If Georgia is listening to this talk, I appreciate his patience with my bugs. Okay, so the last but not least, there is some Huawei internal UCG version. This is because they need to have steady release schedules within HyperMPI, which is what's being released. It contains a few proprietary extensions related to hardware products they have. I actually have very little to do with that code. This is mostly, however, experimental code that is written in the team in the Hangzhou, and it's just not stable enough to be, sorry, I have to say they have more than one branch, obviously, so the ultra stable version is there internally, and they also write some of their own new code. They have very strict procedures about upstreaming code. Mainly has to do with it has to pass a lot of requirements in QA and testing. We should all be so strict on our code quality. I should tell you that. They showed me the checklist they need to satisfy in order to release any code outside. I was like, can we actually ever do that? They found, like, they showed me, this is off topic, I'm sorry, but this is a rant I have to get out. They told me they cannot upstream their version of OpenMPI because it had like 1,000-something issues with their code quality process. And as I looked at it, most of these, almost all of these were not related in any way to code we added. It was just applying their latest static checkers on OpenMPI. They found some stuff. They told me, okay, we have 1,000 issues. Do we now solve them? I said, no, this is an open source code. This is okay by definition. You can just check your changes for quality. And we went with that. And fortunately, they agreed. And Huawei MPI, sorry, Hyper MPI, I'm going to do better. Hyper MPI was published and is available on GitHub. And almost all the code we write eventually will get there, I promise. UCG today, a range of collectives, including Bcast, Reduce, All Reduce Barrier, you would expect those. Also Scatter, Gather, and All Gather, which is now working thanks to these shared memory modifications. Again, just my branch, not the stable one. Any data type OpenMPI supports, because we cowardly defer every non-trivial data type back to OpenMPI pack and unpack. It supports any transport UCT does, right? Because we delegate. I cannot say it supports any protocol UCP does, not even close. We are working on it, and a lot of the stuff Yossi mentioned about transport selection will probably help a lot. I mentioned this in my previous talk, but the main and probably only component we use from UCP, and it's a big component, I'll admit, is the connection establishment. So what we basically do is when we get the remote UCP worker address from the remote process using Modex, we do connect, we get a UCP endpoint, and then we hackishly do get active message lane, and then we use the UCT endpoint from now on. Now that we've added this Bcast and Incast, I added two other lanes, lane for Bcast and lane for Incast, surprisingly enough. So now we use 3 UCT endpoints out of all the UCT endpoints that compose the UCP endpoint, which UCP happens to provide during connection. So connection establishment is important, and we use it. All the rest of the useful stuff in UCP we don't use because it's hard and it's a lot of work for us to kind of combine and use both levels. So that's what we have, and we can talk about that. And obviously supports various platforms. Obviously ARM and x86. We're kind of working on buying new stuff for the lab. I use UCX as an excuse to buy like this exotic hardware and say, okay, yeah, I want to test the UCX on RISC-V, so I'm going to get a RISC-V in my lab. Right, so that's just an excuse, but we're getting more hardware over time, and we tested it on 256 x86 nodes and up to 256 ARM cores on the same host, not 256 by 256, however. I'm afraid we don't have that much compute power. Even the 256 nodes were actually in a German cluster used for academia. We just got a chance to run on a long time ago, I'm afraid. But anyway, that's the state of the art in terms of UCG. Next, I'm going to talk a bit. Yes, go ahead.
Question, Alex, if you don't mind.
Go ahead.
Is
sure,
UCG used in production by Huawei today?
So it is used in Huawei Cloud. I don't have any usage statistics or information, but I know for a fact that they test it with applications. So for example, I'm pretty sure it's public that they use it with the WRF, for example. So if you are on Huawei Cloud and you run any number of applications that are natively there, they are built to use this Hyper MPI with UCG and other UCX components. But again, this refers to this internal stable version they're maintaining, and not the crazy unstable one that I'm developing, which is XUCG in OpenUCX.
Is it enabled by default in Huawei Cloud? Like you have own MPI implementation, right? Or no?
From what I know, like similarly to having these pre-built packages in other cloud vendors, if you want the MPI package, you get Hyper MPI. But I can't provide a lot of details. I haven't used it myself. This is what I was told by the other guys that actually are responsible for delivering it to the cloud business unit.
Thank you.
Sure. UCG in the software stack. So this is another slide I shamelessly borrowed of somebody else in Huawei. This depicts the stack with the applications on top and OpenMPI in the middle. That's actually could be Hyper MPI, could be OpenMPI. I talked about this component for collectives in my talk about UCX roadmap on Huawei, for Huawei. Now I'm going to focus on this part, which is UCG. Not coincidentally, it's like on the same level with UCP because mostly uses UCT directly. And you can see in blue fonts the stuff that we added. So that includes, they actually did some code for UCP. I'm not sure how much I can elaborate on that, but it has to do with, it's still experimental. I'm not sure that's actually used in production yet, but it has to do with the rendezvous protocol and how we can maybe do something clever for some applications. And on the UCG level, topology-aware algorithms and shared memory-based algorithms are most of our work. The black ones are also our work, but not from this year. It was there for a while now. At the bottom, well, that's not fair. RCUD and the transports have already existed before we came into the picture, but the RC and UD for Kunpong haven't. So I mentioned there is a Rocky Rocky ASIC built into the Kunpong 920 chip. So they have their own transports. They have their own transport too. Singular, it's in UCT. They will publish it eventually. I talked to these guys. It will go open source at some point. No change in verbs. The lib for Kunpeng, the one at the bottom, is the provider for RDMA core. So we have a provider for Kunpeng and for 1822, which is the RDMA capable 100 gig NIC that Huawei manufactures, but not very common yet. We have them in the lab though. I tested, it's working. That's fine. So
can I ask
this is
about previous?
Sure, go ahead. Sure.
So I have I'm following RDMA core like verbs. So seems like your Rocky driver is completely upstream, right? In RDMA.
We have an upstream Rocky driver. I know that they're working on some modifications, but yes, libhns I think it's called is a provider, and it's upstream today.
So the question, since it's kind of verbs compliant, right, in upstream, do you use standard RC and UD transport, or you implemented your own? And if you implemented by own, why?
Same as RCMLX5. It does, in most cases, it will work if you use UD verbs, but due to some limitations on the NIC, not all verbs are fully supported. So currently, our suggestion to people who are using this, use only the Huawei, both obviously the Huawei provider, but also the Huawei UCX transport.
So you have something like UD_HN.
Yes. Yes, it's actually UD_1620 after the internal name of the model of the CPU. But yes, that's exactly what we have.
Okay. And like in this non-standard features, do you use this new verbs interface that essentially gives you access to directly to objects, or?
That's a good question. I'm afraid I don't know the answer. I took a look at the code, but I really don't remember.
Okay. Cool. Thank you.
Sure. So I put an asterisk somewhere earlier saying I'm going to work with any UCX version. Pasha saw that and hinted me like, that's a very bold statement, kind of, are you sure that's really what you want? So so far I didn't get burned too much with this decision. We had a couple of incidents. This is just I'm happy to show them because I solved them. Maybe tomorrow something else will come up and I'll be sorry I said that. But so yes, we know, we talked about it many times. UCT is not a guarantee in any way, and the API could change from today to tomorrow, and that's fine. I'm living with it. It changed a couple of times during the development. These two change IDs, they actually have the links. So we changed the UCT completion callback API. We added this parameter, and we used UCT completions for active messages. And the macro for a register table entry changed. So we added this. In our configure M4, it basically checks like how does the completion callback look like. So this means during compile time, it doesn't really care about the version of UCX. It does, however, care about if the API is this way or that way. So you can imagine if I want to backport it to a very old UCX, it is possible. I'll just have maybe 3 or 4 more of these, and I will probably be able to work with multiple UCXs as long as it's not like contradicting behavior. Usually the code flow is the same. It's just one parameter more or less, so that's easy enough to overcome. So as far as I know, unless somebody tells me otherwise, today UCG works with any UCX version starting with version 1.6, which is what I actually started with. So that's that. I'm not going to go deep into, well, depending on the time. I am going to talk a bit about APIs. So I was conflicted if I want to go over APIs because I did this both last year and in some of the working group sessions. I will say some of the things that changed very recently, and by recently I mean in the last month, maybe. So as I was preparing for another internal release with our colleagues in China, they pointed out some things I left out from the original API. So I have so I wear the proud badge of this X UCG being experimental. So I don't feel bad about let's just say radically enhancing the API of UCG. So I did. And I'll just briefly start by saying, obviously, we have a northbound API, which is UCG.h, which has functions like UCG group create and collective create. We actually have maybe just a dozen of functions, and not even close to the number of collectives we support or intend to support at some point. We also have, which is something I argued for in UCC, but I'm not sure we're quite there yet. I have a special header for UCG called UCG MPI, and I expect I will have other specialized headers like these in the future for, I don't know, TensorFlow or PyTorch or whatever. I'm not an expert on these, but I will say it made a lot of sense to me, and it still does, to have exactly what the client application or consumer application needs in my API, And actually, UCG_MPI.h is a horrible file full of macros that translates from exactly the API that MPI reduce uses to the API that UCG actually exports in UCG.h. So to clarify, because I think this was kind of not a very clear sentence, we have in UCG one general purpose API, and we plan to have several domain specific APIs, which are just translating from the domain specific request to the general purpose request. Today, we only have one domain, which is MPI. We assume we will have more down the road. Also, we shamelessly copied UCG version from UCP version. It behaves exactly the same. So just a side note on that. As to Southbound, why do we have a Southbound API? Because we presumably want to have modules. Originally, I was naive and I thought, yeah, we're going to offer this component framework and everybody's going to put components in it. That did not happen yet. But I did work over time also on the component API, planning that. So first, Huawei as a requirement told me, well, we want to at least support the option of having an open source and a proprietary component. Today, the proprietary component is only returns unsupported. That's also true for the internal version. Everything is built-in, which is the basic component that does everything today. And I don't know, one day we will put nickel, and Huawei has some of its own accelerator cards, so maybe that will turn into another collective module. I don't know. But we keep a component API for that. I'm not going to go over that because that's really very technical. Northbound API with the latest changes going once. On the left, you see an MPI application calling a blocking bcast. On the right, you see UCG, the general purpose API. As you can imagine, the domain-specific API is just one call. It's a kind of a UCG bcast, right? Then it has practically the same parameters, so it's not interesting to show. But I will say UCG accepts structural parameters. I worked really hard to make it exactly 64 bytes. So that means it fits in a cache line, the size of all the parameters for a collective. I used ugly bit fields and everything I could. And the reason, I'll get to the reason in a minute, but you pass this parameters structure, which is 64 bytes to create. That creates some handle, and this handle can be started and also, originally that handle would be also used for waiting. I found, because something I mentioned to you before with the MPitch, I wanted to use requests allocated externally. So I now, the good Boy Scout that I am, I use OMPI request T for this, for requests in OpenMPI, and presumably in MPitch I'll do whatever they do for requests, and I use MPI wait on those. So basically, if you're thinking, oh, this API would be very good for non-blocking or even persistent collectives, I'm glad you noticed, because that's exactly what we were aiming for. You can do on the left MPI ibcast init, which would translate into create this bcast but don't start it. And still on the left, you can start it over and over again, as long as you wait for it, because the same request, this in here request is misleading. It should be a handle. So as long as you only have one concurrent collective running on this kind of handle, you can rerun it over and over again, saving time on initialization, presumably the entire point of persistent collectives. So in the spirit of persistent I will just say on the right, you'll see almost the same. You'll see the creation and you see the collective start and the non-blocking wait. It's actually an MPI wait and not, I know that the UCP uses this UCP check request status. I don't. I use native MPI stuff, and presumably in MPC I will do something similar. And now I'll say, in the spirit of persistent collective operations, what I do in many of the cases where I get a collective and it actually matches a previous collective, I kind of do transparent persistent collectives, and I try to reuse the previous structure. So even if you call this MPI bcast, you might end up reusing something previous with the same parameters. And this is the reason why it's significant to have a small params structure. I actually, if you look at my code, there's only one thing I didn't upstream in UCS, which is kind of weird because it's very general purpose. It's comparing exactly one aligned cache line. So the reason I have this is because I'm comparing the aligned cache line of parameters to an aligned cache line of parameters for previous calls, and then I reuse previous structures, and everybody's happy, especially OSU. Applications, maybe not as much, but still probably very useful. Again, stuff for further research. We didn't have a lot of runs with applications. I'm busy adding experimental features full of bugs, and somebody else gets to do all the boring work of fixing them. Right. So I'm kind of, I don't know, I'm kind of reluctant going over this because it's, I don't know, it's a bit intense, and I think you get the point of it. I'll go over it a bit, and if you're really interested, you can ask me questions, and I'll talk about it as much as you want. I talked about it a bit in the past about decoupling planning from execution. So this essentially means I'm trying to decouple this initialization phase, which is here, this ibcast init, from the MPI start or UCG collective start, which I do here. So the logic is, at some point, if I'm trying to do a recursive doubling reduce, which is what you see on the screen right now, and you are here, your process number one, you initially prepare the phases. Phase one would be to send to rank 0, phase 2 would be to send to rank 3, etc. So you prepare all these phases and you don't use them, you just put them aside. And at some point, somebody calls start, and then you launch these existing phases, and you don't have to recompute anything, and all the buffers are presumably ready. This is very good for complex collectives that need temporary buffers. This is probably not very important for small collectives like where you just send one or you just receive one. It makes little sense, but still, that's what we have. So for trees, we actually do something more clever, because we have one structure for the entire, one plan for the entire tree that's on the left. So suppose you're rank number rank number 1 on the left, that's you are here. And if you want to call MPI gather, you do the first 2 phases, which is wait for your children, also known as fan in. And if you're doing a bcast, you're doing only the last 2 phases, which is a fan out. I'm not sure it looks much because it's kind of saving us 2 phases in a data structure and doesn't consume that much memory anyway. But it made a lot of sense to us because we thought there's going to be a lot of trees, and fan in and fan out on the same tree is kind of obvious. So we wanted to save that. On the right, I showed a lot of details I didn't mention. This is the kind of the transition from left to right is the kind of transition you also want to do just once, but you need to do more often. On the left, you see just the topology. On the right, you actually see like how many buffers are going to be sent, and this has to match the parameters of the input that you got. So if I call MPI bcast, I know which plan to use. But if I call MPI bcast with 8 bytes and then with 30 bytes, that will be different steps, which is what I see on the right. I'm not going to go into much detail, but I am going to say the spirit of things is to reuse previous data structures as much as I possibly can. That's the entire goal. And this is presumably how we could get pretty decent performance with OSU. One could argue we cannot replicate the same performance with applications, but fortunately enough, clients really care about OSU for some reason. So we play the game. Now I have a warning, controversy ahead. I have at least 30 minutes to argue with people. So I'm going to present some thoughts on UCC, including some challenges. So brace yourself, here goes. UCC is coming about slowly but surely, as Manju mentioned, and Huawei is also in it, and I give in my regular reports to headquarters, I also update on the status of UCC, and they're interested in it, and they're asking me how's it doing and what am I doing to help. So certainly it hasn't escaped the radar. It's not just me, the crazy Israeli guy, hacking away code. However, UCC also looks to me like a big performance risk. Doesn't mean it shouldn't happen. It just means we need to pay attention to this. And here are a couple of things that, in light of my experience with UCG, I would like to point out. To be fair, I think I did a fair job at pointing this out during our working group sessions, but I feel like our working group sessions are somewhat limited. So this is also something I'm going to raise later. So. One example is something we kind of raised during my talk about shared memory, which is the way we're looking at UCC today is because it's looking at UCX from the outside, it's kind of limited to the API exposed today, which is UCP. So if you're looking at something very low level, like you want to decide if this reduction should use atomic operations or not, you really want to know what are all the capabilities of the bottom layers. You really don't want this kind of a nice abstracted world that UCP provides where everything is possible. It just might be software simulated. So I can really see why this is useful for MPI. I can really see how this hinders the development of the algorithm selection in UCC. So that's a challenge. I am sure we can address it. We're all engineers and we can solve it, but this is something I should point out. The second thing is, which also stems from the same problem of abstraction, which is, I remind you, the root of all evil, and not premature optimizations like you thought before. Progress is not aware whether sharp is used at the moment or not. So we have these kind of disjoint components where the lower component does progress regardless of what the upper component needs. So for example, I took sharp as an example, but really any other transport which might or might not be used is actually progressed without due cause. And I'm not sure today we have a good way in UCC to tell, okay, now you progress it, now you don't, or have some kind of reference counters. We really want these kinds of things. And we certainly talked about these during planning, but I feel like today we're saying, okay, that's tomorrow's problem, but like this is one big problem we should really at least acknowledge. Okay, so that's the first. The other two, in case I haven't rained on the parade enough, is today, and I fully acknowledge my shared responsibility here. The development is kind of breadth first and not depth first, and by this I mean, though we do want to have initial results in Q1, like Manju said, it kind of feels like we're today trying to map out all the components and how they're going to play together. And we haven't yet for a while now. And I remind you that according to the timeline, we're at least a year from when UCC was announced. And by then we already had some collectives code on both sides. We don't have preliminary results as to like all the stuff we're talking about in the working group. How is it going to perform? Maybe it's going to perform well, maybe not. We don't know yet. We only know in Q1, which is in feature terms, that's quite a few features away from today. So that's 2, 3, and this is something I really want to use this community forum to encourage, and Manju is doing the same. Practically, if you log into a working group meeting any time in the last, I don't know how many months, it's only Mellanox and Huawei. So obviously, clearly, we're missing representation. I'd say other vendors and potential users to begin with, but obviously academia, and I can think of any number of other parties that probably would be interested, and we would be interested. We would welcome them to UCC. So with that, challenges looking forward. I know this kind of turned into a UCC talk. I'm going to switch back to UCG soon, I promise. So one challenge is we must show the approach is beneficial, and before investing so much effort with all the planning we do, I'm not sure how XCCL's or XUCG's individual performance is proof of what we're going to have in the combined approach, because we actually try to add levels of abstraction to cover for the fact XCCL and XUCG work differently. We talked about a hierarchical versus reactive approach, and we said, yeah, we're going to accommodate everybody, which is all nice and well, but you can imagine that'll cost us. So I need to be able to justify the effort we put into the development here. And so that's something that's important to me, especially in light of the fact I can't hold on UCG. UCG has a team in China that's always developing new features. And it's like I need to say, okay, UCC will be better than UCG in XYZ in order to say, okay, let's move on to that. Next is obviously community involvement. Stemming from the previous item, I would really like to see more people contributing. This is also a pain point for XUCG. Clearly, it's not a good idea that all the developers belong to a single vendor, and even more so if it's a community project like UCC. We really want more stakeholders like you see in the picture. That's very useful. And last but not least, we obviously want to deliver some relevant and high quality software. So if UCX won the R&D 100 award, I don't see a reason UCC wouldn't down the line. We just need to, get there. So with that note, I'll get back to UCG and what we're gonna do in the short/medium term, because long term, who knows? UCG is not going anywhere because it's used and we don't have an open source alternative yet. On the right is a slide I already made, so might as well put it in the slides again. I made it for the working group, and what it describes is like how I can manipulate the blocks we already have to kind of create UCC to encompass everything we did so far. And it's a mess, I know, but with that said, I see 3 possible paths for UCG, and if there is any takeaway from this talk, this is it. 3 possible paths. 1, merge into UCC. If UCC is, if I can prove that indeed this is the right path from several perspectives. And by perspectives, I mean both performance and community and standardization, stuff like that. Second option, merge into Huawei's UCX package. If you're wondering what's in Huawei's UCX package, it's basically an old UCX version 1.6 with some backported features. Like every once in a while, they come across something that is not supported in the old version and is in the new, and I tell them, look, here's how you can backport it, and they do, unfortunately. So I can see why this is important, and I can see them telling me, look, like it's time, UCG cannot stand on its own, we should put it as part of the code and be done with it. And last but not least, merge into Upstream Ucx. You probably felt a hint of this when I talked about shared memory transports and how they are kind of these Siamese twins with the point-to-point transport. So clearly you can see on the right how transport-specific transmission, that's the green box to the top right, goes down and enters UCT. That's wishful thinking at that point. At this point, I know. Also, some other stuff you can see as reactive RX engine, which is what I thought, what I distilled UCG into when we were talking about UCC and how that should work. So a bunch of stuff from reactive RX engine would probably need to go into UCS. Some of them already did. Actually, both of these blocks did. Oh, yeah, added to UCG. Green means added. And by added, I'm not necessarily saying upstream, though the bottom two were, and the shared memory collectives were not. So that's the three paths I see before us. I'm not sure we're going to get an answer today, but I'm going to present what I present. And last but not least is a bit about Huawei's roadmap for collective operations. So this might be a bit vague because I pitch ideas all the time and I get requirements from the business department all the time, and it's a moving target to cover this roadmap thing. But I will say there are three main directions. One is hardware-specific capabilities. Second is integration with related HPC software developed by other departments in Huawei. And the third is custom acceleration hints. I gave these examples before, the read-only, write-only, and persistent operations is the part where I kind of guess that you wanted the same operation again, and then I reuse data structures. So on the first one, I should say, aside from the Kumpong CPU that I kind of advertised in my first talk, there are also the storage product lines and the Atlas AI accelerators, which are probably equivalent to GPUs to any developer. It's just a PCI card, and you offload your AI jobs too. So obviously, we would like to see those part of the what Huawei sees as the entire HPC software stack, and I see as UCX and the Hyper MPI. Second is integration with related HPC software that includes storage and parallel file systems, not the proprietary ones, but actually the open source ones that's in MPIO, for example, but also stuff like Lustre. A batch scheduler, I wrote Slurm because I'm not sure. I'm pretty sure actually the Huawei one is not out there, but it is under development. Huawei is developing a batch scheduler called Donao, which is going to be out there sooner or later. And builders like SPAC, we actually have members of my team working on applications. So one of the things they do is they say that now the default build parameter of the application actually makes it use UCX or some specific optimizations. So clearly, I would like to see applications using this library directly for collectives. I'm not sure if that's so soon, but it is somewhere down the road, so it's on the roadmap. That's basically it. I have 15 minutes to talk it out. Any questions? Wow, that's more silent than I expected.
So, Alex, so I'm puzzled. I mean, so we've listened to you talk for like an hour on this, and I'm still trying to understand. What is Huawei's plan to get UCC into production?
UCC into production?
Yes.
UCC is not, I'm not sure that UCC today is at a point we can say, yes, this is certainly going into production. This is a community effort to see if we can build a library that would compete with what we have today. And if it is, we can move on from there. But I can't tell you if we don't even have a single running collective yet, what's the plan to make it production, I'm afraid.
So again, why is that a community problem?
What do you mean? UCC is a community project.
Huawei problem.
Hmm?
We have collectives. I mean, You don't have collectives, it sounds like.
I'm not sure I understand.
I mean, I don't understand when you say it's a community effort, but then you make this statement about Huawei doing this as kind of an R&D experimental, go see if this works or not. I mean, that's not a path to getting like production grade software, right?
Yes, but clearly we are. We have.
I'm trying to understand what's the plan. I mean, and why should the rest of us hold up if you guys are just out there, just experimenting and writing PhDs? I don't understand what the end game is here.
I mean, I'm not sure.
I think let me.
Controversial slide. So let's get controversial, I guess. I mean, I don't understand.
I think maybe the right question is like, right. I mean, today we don't have any code, right? We can't really say. I think it's right to be skeptical about what is going to be built, right? I mean, we don't know what we are going to. But I think what we want to say is we have a right ingredients. I think we had many discussions about how we came at this API and how we want to merge these multiple efforts that's going in the community with the both, right? I think what I think question would be right, like how we want to combine the efforts, definitely as soon as possible, right? But sometimes these things time and effort to get there. And I think that's a way we have to converge. If not, we will not have a community effort, right? And probably question is like how we get there, right? I think this is as a goal, as a working group, we kept us like, okay, we will merge these efforts eventually. And right now we have a number saying that, okay, we'll try to do by Q1, right? And go from there, right? So, and if we can't see a good performance in a scalability, right, we have to question ourselves why, right? And is this because in a particular OSU benchmark I can't beat the results, or is it something that we are not building any stack for a OSU benchmark, and that's a wrong approach, and in my opinion, wrong thing, right? So if we can't build it, what is that's going wrong, right? We have to question ourselves that. It's good to have that be skeptical about it. That makes us come up with a better design, and we can come up with a better implement. So, and any new project that you start, we'll have this initial anxiety and skepticism. I'm not concerned. I think long term we need to figure out why we can't get it there, right? So.
Yeah, I agree. I'm not sure it answers Josh's question.
Yeah, my organization and my group, I mean, our job is to produce, production grade software at the end of the day. We're investing in this, company resources, software engineers. I mean, we have teams of people, QA, all this stuff, right? I mean, the goal is to get this into production someday. It's not a research project. So I just want to make sure that we're all aligned here, because what you said, Alex, sounds like stuff that you're working on, or your vision is like a research kind of sort of nebulously defined objective.
It would seem so.
Maybe it's something Huawei wants, maybe they don't.
We don't want it at any cost, right? If we see that based on the initial results we have, that this is not the right way to go, as a for-profit organization, we will probably choose a different path. We invest some resources in UCC, but we don't put all our eggs in one basket.
So you have been working on groups for 2 years. So do we have results that would suggest to your management that this is a good technical direction?
By good, it needs to be compared with other methods. Yes, I suppose we do. Yes. I mean, I can't compare it to UCC because we don't have results yet, but the only thing I can compare it to is to existing libraries, and I think we're doing well there.
meaning like running applications, well in benchmarks. Like I don't even know what that.
Yeah, that's exactly what it means. You got it right.
So the right question, I think, to ask here is, for you, Alex, question is, like, at what point you think, like, it is okay, I think all vendors that work on UCC right now, they have own solution, right, that kind of run in parallel. So it's completely fine from my standpoint. And once there is enough mass behind, UCC, people will start to shift their efforts. So the question for you, at what point you think UCC will have enough critical mass for you to start to make context switch?
That's a good question. I'll say I'm flattered if you think I actually make the decision. The decision is probably above my pay grade. I said I advocated to invest some time, both mine and the time of my team in this, and headquarters said okay for this amount of resources. So right now I have reports to them once in a while, and they say, okay, this is the progress, that's fine, move on. And at some point, maybe they'll say you should move, and maybe they'll say I should focus all my efforts on UCC. I can't make that call. But I suspect that once UCC starts producing results, those results will naturally be compared with the ones they have today from UCG. Make sense?
Yeah.
Alex, this is Steve.
Go ahead, Steve.
Sorry, Pasha. So Alex, other than yourself, do you have people who are testing UCG on, let's say, on Mellanox hardware?
Oh, we actually mostly test it on Mellanox hardware. I'm afraid that aside from aside from the recent obstacles in procurement, most of our hardware is actually most of our hardware interconnect is from Mellanox, and most of our servers, I'm afraid, are x86, and the ARM is fairly unstable because they're developing, like, a lot of components are being developed at the same time, so testing on those is not producing results that I'm happy with. So it's kind of too early to share those, I'm afraid.
I guess my question was too subtle. If you had someone else to be able to do some of the testing, would that be of interest to the UCG community?
Of course it would. I think you also flatter me by saying there's a UCG community. There aren't as many people as one would imagine behind the UCG, more than one, admittedly. Yes, I would really love, I would really love somebody to test UCG at more scale than I have in my lab, which is very humble, as you've seen from Morad's results. He's not to blame for the small scale we tested on. And yes, of course.